I will tell you a story first. There was a zoologist. He was a great scientist. He was carrying on some research on cockroaches. He conducted one experiment one day. He caught one live cockroach and put that on a table. For those who do not know, let me tell that a cockroach does have 6 legs. The zoologist started his experiment, taking all cares and precautions for the experiment to be flawless. He ordered the cockroach, run. The cockroach ran from one end of the table to the other end. Then the zoologist took a pair of scissors and cut one of its legs. He then ordered, run. The cockroach ran this time also. He then cut its another leg and then ordered, run. The cockroach ran this time also, but not so comfortably, as it had only 4 legs left. The scientist cut its another leg and again ordered, run. The cockroach was left with 3 legs only. It ran this time also, but with very slow speed. The scientist then cut its 4th leg and ordered, run. The cockroach obeyed the order and could anyhow made a little movement. Now the scientist cut its 5th leg and ordered, run. This time the cockroach couldn't move at all, but a little vibration in its body was observed, which indicated that the cockroach tried its best but failed. Then the scientist cut its 6th leg, the last leg, and ordered, run. This time there was no response in the cockroach, not even any little vibration in its body. The experiment was over. It was conducted very carefully in a controlled, normal situation. Now it was the time to draw conclusion of the experiment. It was time to interpret the result of the experiment. Should I tell you what was the conclusion of the great scientist? His conclusion was that if all the legs of a cockroach are cut, then the cockroach becomes deaf. What a funny conclusion. This makes all of us to laugh. But I think that in most of the cases nowadays, we do such type of mistakes in interpreting the results of a statistical analysis. Very often in newspapers and magazines, we find several interesting, ear-raising results of the experiments conducted by researchers, such as drinking tea prevents cancer, lemon juice is more effective than chemotherapy, regular intake of a little dose of alcohol raises the HDL level in blood, etc., etc. Next day we find results of some other researchers quite different from the previous ones. I do not claim, but I am of a strong belief that in most of the cases, in interpreting the final results of the experiments, we do such type of mistakes. A statistical analysis of data and interpretation of the results of the analysis are the two major parts of a quantitative research. A statistical analysis of data is not a problem nowadays, as so many statistical software are available. Nowadays, it is the task of computers. Computers are very intelligent in this respect, and they perform this task with full perfection. But interpretation of the results do not depend on intelligence only. It depends on wisdom also, which computers do not have. It can be done only by those who are full of wisdom. If you conduct your experiment with all precautions, following all principles of designing of an experiment, apply sophisticated statistical tools for analysis of data, but if you do even a slight mistake in interpreting the results, your whole effort goes in vain. Your whole research is ruined. Very often we do mistakes in determining the independent and dependent variables. And so our results get misinterpreted. I remember one instance in this regard which happened with me. One day, a senior professor of economics of a reputed research institute in Patna came to me. He was doing some research on establishing the relationship between crime and police force in the state of Bihar. He had calculated the correlation coefficient between the number of crimes and the strength of police force. The correlation coefficient came out to be positive, and that also very high. He was very much perplexed over the high positive correlation between crime and police force, as it is expected that there should be a negative correlation between these two variables. He came to me to find a plausible explanation for this positive correlation. He asked me first to check the calculations, and after checking carefully, I found no error in the calculation. But how can crime increase with increase in police force? He exclaimed. I told him to interpret it just other way. Police force increases as crime increases. Obviously, to check the increase in crime, police force is to be increased. He was so delighted and felt relief on my this interpretation that he stood and hugged me and patted my back. Several times, correlation coefficient is wrongly interpreted. Once a research worker, out of sheer curiosity, obtained the correlation coefficient between marks in the theory papers and marks in the practical papers in an examination. The correlation he obtained was much weak. He was highly but unnecessarily surprised and irritated. He argued with me quite vehemently that as there is low correlation, practical examinations are unnecessary and should be done away with. I tried my best to impress upon him that I would have readily agreed with his suggestion had the correlation been very high. Very frequently, people make wrong comparisons of percentages. A man argues that as in a very small percentage of total road accidents, women drivers are involved, whereas in a very large percentage of accidents, men drivers are involved. Women are better drivers than men. One may easily be misled to this conclusion, no matter how unbelievable it may sound. Policymakers' understanding of statistics and interpreting statistical results sometimes create funny situations. In a health survey report, it was mentioned that 3.2 persons out of 1,000 suffering from a particular disease died during the last year. The health minister asked his private secretary, who was an administrator, the meaning of this. The private secretary interpreted the results according to his understanding, and he replied, "Sir, when statisticians say that 3.2 persons died, they mean that 3 persons actually died and 2 are at the point of death." In another report, it was given that a middle class family have on the average 2.2 children. A royal commission, while reviewing this report, remarked, "The figure of 2.2 children per female is clearly absurd. It is suggested that the middle classes be paid money to increase the average to a rounded and more convenient number." What funny interpretations are these? People generally fail to find the third factor that may create an association between two attributes, because both are actually outcomes of the third factor. Let me give you one example. There might be an association between the habit of eating at hotels and better cardiovascular health. This might lead us to believe that eating frequently in hotels makes our heart healthy. But this might not be true. The reason may be that those who can afford to eat in hotels regularly are from a high socio-economic class and can also afford better health care. And it's the health care that affords healthy heart. There are several general examples of making wrong interpretations of statistical results. Interpretation of results must be done wisely and very carefully. I would close my talk by telling you another interesting story of doing correct calculation but doing blunders in interpretation of the results. There were the great astrologers. One day, he went to the king's court and requested him to appoint him as the king's royal astrologer. The court, that is the darbar, was full, and the king was sitting on his throne, Singhasana. The king started talking to the astrologers, and in the meantime, he slowly and secretly pulled out his wings and kept that. Then, to test the knowledge of the astrologers, he asked as to what was there. The astrologer started doing calculations, and through his calculations, he came to know that the object that the king has kept was round and there was a hole in it. Then he, out of joy, exclaimed loudly with eureka feeling that it was Chakki. It was Chakki. The astrologer was the super master of astrology. His calculation was perfectly correct. But he didn't have that much wisdom to interpret the result, keeping in view the place, the size, and Chakki. This is what we sometimes do in interpreting our statistical results also. Thank you.
On high demand from worldwide. Upcoming sessions of Professor Dr. Amarendra Mishra will be on theory of hypothesis testing in 3 parts. Stay tuned. Stay safe and keep learning.